Good day, everyone. I welcome you back to Global Education Zone, the home of impactful learning. It's nice over here for you and I because learning never ends and education is the key to an impactful life. Good day, everyone. My name is Anthony Nathaniel here again, and today in this particular episode of our Crash Mathematics for SS3, we are going to be dealing with graphs, and not just graphs, trigonometric graphs. Now, in your previous knowledge and understanding of mathematics, you would have understood that trigonometry is basically that part of mathematics that deals with your angles, your lines, and so on and so forth. Your trigonometric ratios, your Pythagoras theorem, and so on and so forth. Now, those parts of trigonometry, they are aside from this aspect. This aspect is a little bit just like a step further. That is why it's part of the SS3 mathematics syllabus. Now, and today we are going to be delving into that, and we are going to be addressing it. And first of all, we are going to be talking about the four quadrants. Now, the four quadrants, they are the four 90-degree sections of a circle. Now, for example, if we have a circle has a point at the center. Assuming this is the center of the circle, and we draw these four lines, each one of them at 90 degrees to the ones adjacent it. So that means this one is 90 degrees to this one, which is adjacent it. This one is also 90 degrees to this one adjacent it, and this one is also 90 degrees to this one adjacent it. Now, in this particular case, what we are doing here is we are going to be looking for the value of the trigonometric ratios using these quadrants. Now, in your secondary school, in your earlier secondary school mathematics courses, you would have been made to understand that you have your sine as your opposite over hypotenuse, your cos as your adjacent over hypotenuse, and then your tan as your opposite over adjacent, right? Now, and then those values of sine, cosine, and tangent, they were given in the first quadrant only. Now, let me explain why. Because now, if this is positive of y plus y, and this is negative of y minus y, this is positive of x plus x, and this is negative of x minus x. So you can see that any angle that is in this region is bounded by the positive axis. So that is why your angles which you were dealing with in your earlier secondary school career were all positive, because you were all in the first quadrant. So this is the first quadrant. Now, when we talk about the second quadrant, the third quadrant, and the fourth quadrant, we have the negative component of these axes. For example, when you talk about the second quadrant is enveloped by your positive y-axis and your negative x-axis. When we talk about the third quadrant, your third quadrant is enveloped by your negative x-axis and your negative y-axis. When we talk about the fourth quadrant is enveloped by your positive x and your negative y. You can see that this is a mixture of one or more negative components. So that is why one or more of your angles must be negative if it falls in this second, third, and last or fourth quadrant. Now, we even have a mnemonic for it, because we say this is all angles are positive, this is sine only is positive, this is cos only is positive, and this is tan only is positive. Now, the reason why I'm saying sine, cos, and tan is because sine is the short form of sine, cos is the short form of cosine, and then tan is the short form of tangent. So, just in case you hear me saying the short forms, I'm still saying the same thing. Now, having understood this analogy, let's use this. Let's assume angles. Now, angles, they are the degree of rotation between two lines, right? Now, if I draw a line and measure the angle of this line with the horizontal and measure it as theta, now I can calculate the sine with respect to this angle. I can calculate cos with respect to this angle. I can also calculate tan with respect to this angle, and this angle is in the positive or the first quadrant. Now, let's turn over to our diagrams. Let's be able to see this visually. Now, let's talk about the first quadrant. The first quadrant is a quadrant that involves angles between 0 to 90 degrees. So for the first quadrant, your 0 will be less than theta, and theta will be less than 90 degrees. So that is the inequality for your angles in your first quadrant. Now, in this first quadrant, you can see that your theta is in the first quadrant, and that theta is the angle that is made by your arbitrary line, and that and the horizontal. So that is what theta is, and when you calculate theta, is always positive for your sine. So for your sine, you actually take the opposite over the hypotenuse, because the opposite of this of your sine, in this case the opposite is the side that is being faced by the angle. So if you reverse your perspective, you see that it is actually the y that is the opposite, because the y is the vertical part, and you can see that the angle is facing the vertical part, so that's vertical is the y, that's plus y. Then your horizontal is plus x. So your the length of your line, let's call it r, so that is plus y over r. So you can see that they are both positive. That is why you have that sine theta is plus sine theta, and then in your first quadrant cos theta is plus cos theta, then in your first quadrant tan theta is plus tan theta. That is why everything is positive. Now if we go on to the second quadrant, this is a very different case. For example, as you can see in the second quadrant now, which we are in now this angle, it is measured from the positive x-axis. So even though it is in the second quadrant, you don't measure it from the negative x-axis. So even though it is the second quadrant, you measure it right from the positive x-axis. Now you can see that when you measure the angle from the positive x-axis, you draw the angle anti-clockwise. So the angle is measured anti-clockwise. When in trigonometry, our angles are measured in anti-clockwise direction, except in bearing and distance, which we are going to be talking about in a further episode of this course. Now in this particular episode, we are going to be making use of anti-clockwise measurement or counterclockwise. And what I mean is that you measure in a direction that is opposite the direction of your time or clock. So the direction that your second click, your minute, and your hands of your clock click and tick, that is the direction will be going, but it will be going opposite. That's counterclockwise, opposite direction. Now this angle, as you can see, is measured from the positive x, and when it goes on to meet the line, you can express the value of the trigonometric ratio of this angle with respect to the first quadrant. For example, you can say that sin theta is plus sin open bracket 180 minus theta. You can also say that cos theta is minus cos open bracket 180 minus theta. So and then tan theta is minus tan 180 minus theta. So you can see that in these three trigonometric ratios, only your sine is positive. So that's for the second quadrant. Then let's move on to the third quadrant. The third quadrant has a limit of 180 less than theta less than 270 degrees, as you can see. And lest I forget, the second quadrant has a limit of 90 is lesser than theta is lesser than 180. Now in this third quadrant, you can see that you still measure your angle from your positive x-axis. So you measure down till it gets to your line, and then when it gets to your line, you call that your theta. And you can see this as theta 3. It's still okay. You can see this as theta 3. You can see it as theta. But in this case, we call it theta. So this is theta, and this theta in this third quadrant. Can you guess which one is positive and which one is negative? So if you look very very carefully, which components are negative? So the ones that contain the negative components will be the ones that will be negative. For example, your sine is negative in the third quadrant, but your cosine is positive. Why? Because your cosine is given as the opposite, the adjacent over the hypotenuse. Now that is why it is positive. So your cosine is positive in this case. Or rather, your cosine is negative, but your tan is positive in this case because your tan is opposite over adjacent. So you can see that because you are using both the negative components of the Cartesian plane, that is minus y and minus x. So because of that, so when you divide negative numbers, they give you positive numbers. The same thing when you multiply negative numbers, they give you positive. So that is why, since both components of which tangent is constituted, since they are both negative, that is why tangent of an angle in the third quadrant is also positive. So your sin theta is minus sin theta minus sin open bracket theta minus 180. Your cos theta is minus cos open bracket theta minus 180. Your tan theta is plus tan open bracket theta minus 180. You can also see this as 180 minus theta or theta minus 180, depends. So if you are given the actual angle, you have to look for the value. So you'll be making use of 180 theta minus 180 because your angle will be greater than 180. But if you are not given the angle, but you are looking for the angle in the third quadrant, you make use of tan theta minus 180. So that is the value. So in this third quadrant, you can also see that only your tangent is positive. That is why we have it as t. Sorry, only your tangent is positive. That will be the fourth quadrant though. Only your tangent is positive in the fourth quadrant. Yes. ACTS. In the third quadrant, only your tangent is positive. Then in your fourth quadrant, only your cosine is positive. So you can see that in the fourth quadrant you have your sine theta is equal to minus sine 360 minus theta. That's the sine is negative. Then you have your cos theta is plus cos 360 minus theta. Your cosine is positive. Then your tan theta is equal to minus tan theta minus minus tan open bracket 360 minus theta. So your tangent is negative. So to summarize, in your first quadrant your sine is positive only. In your second quadrant your cos is positive. In your second quadrant, yes, your sine is positive only. In your first quadrant, all your trigonometric ratios are positive. In your first quadrant, your sine, your cos, and your tan, they are all positive. In your second quadrant, only your sine ratio is positive. Then in your third quadrant, only your tangent ratio is positive. Then your last or your fourth quadrant, only the cosine ratio is positive. So that is all for the angles between 0° and 360°, and these are the angles that we'll be dealing with in this question. And in case you are given angles that are greater than this, all you need to do is you are going to subtract 360 from that, and you are going to calculate the effective angle. So this is beyond the scope of this video, but I will just give a little bit of illustration. For example, so I made a mistake here. This is actually supposed to be T. Tangent is positive only in the third quadrant, and then this fourth quadrant, cosine is positive only in the fourth quadrant. Now, for example, if you are given an angle of 540°, now you can see that this is beyond 360. So what you do, and you are looking for the sine ratio, the sine of 540°, all you need to do is you are going to just subtract 360. That's sine 540° equals to sine 540 minus 360 equals to sine. So 540 minus 360, that's sine 180. So that will sine. So you can see that this falls within the second quadrant. That will be sine 180 minus 180. So and then sine is positive. So that's sine 0. So and sine 0 is 0. That is the actual value of this. So anytime you are given angles that are beyond 360, if you are actually given, then you have to subtract 360 from that angle and then calculate the value of that angle using the four quadrant formulas. Now that is all for this that section of this video. Now let's move on to the next section of this video, where we'll be dealing with questions and examples. Now for these questions and examples, we have example 1 as well, looking for the sine, cosine, and tangent of the following angles. So now this example, we are given our sine 153 as plus 180. Sorry, we are given the following angles. The angles we are given here is 153°. We are given 204°, and we are given 320°. So what we are looking for the sine, cosine, and tangent of the angles. Now these are all positive angles. We are going to be doing the one of negative angles shortly, but now these positive angles, they are simple enough. All you need to do is you just need to figure out which quadrant they fall in. Now you can see that this 153°, it falls in your second quadrant. You can see that your 204° falls in your third quadrant. You can see that your 320° also falls in your fourth quadrant. Now what you are going to do is you are just going to be using the predefined formulas. So you know that your sine is positive, so that means your sine 153 will be equal to plus sine open bracket 180 minus 153. That will be plus sine 27. Your cosine is negative in your second quadrant, so that will be cos 153 equals minus cos open bracket 180 minus 153. That's minus cos 27. And then you evaluate that using your four figure tables. Same goes for tan 153 is negative. Then for your number B, you have sine 204°. So now this 240° occurs in your third quadrant. So all you need to do is you are going to note which ones are positive. In your third quadrant, it's obvious that only the tangent is positive, right? So now in your third quadrant, every answer is going to be positive, it's going to be negative except your tangent. So you can see that it's demonstrated in the table. You have your sine 204°, sine 204° equals minus sine open bracket 204 minus 180°, close bracket. So that will be minus sine 24°. So same thing for your cos and same thing for your tan. Then for the last part of the question, we have 320°. So in your third quadrant, in your last quadrant or your fourth quadrant, your sine is negative, only cosine is positive. Sine and tangent, they are both negative, so only cos is positive. So that is even demonstrated in the answer here. You have your sine 320° as minus 0.6428. You have your cos 320° as plus 0.7660. You have your tan 320° as minus 0.8391. So that is an illustration of the fact that I'm trying to show in this video. Now let's move on to negative angles. What if you are looking for negative angles? Now, when you are looking for negative angles, all you need to do is you are going to measure the angles clockwise. So negative angles are angles that are measured clockwise. Now, what this means is that if you are looking for the negative angles, you just subtract that angle. You just add, you add that angle to 360. So that will be 360 plus that negative angle. So, or in other words, you can just say 360 minus that angle, minus the absolute value of that angle. For example, you can say that in this example, example 3, we have find the values of the sine, cosine, and tangent of the following angles. Now these angles are minus 60 degree and the second is minus 210 degrees. So now you have sine minus 60 degrees. You measure it clockwise instead of anti-clockwise. So sine 60 degree, sine minus 60 degree will be equal to what? So if you are measuring this angle clockwise, all you need to do is you are going to add 360 to the negative angle. So that will be sine minus 360 degree will be what? Sine minus 360 plus 3. Sine minus 60 degree will be equal to sine 360 minus 60. That's sine 300 degree, as you can see. So and then you will now look for the sine of the sine convention, not the SINE, not sine ratio now, sine convention. You are going to look for the sine convention of that angle in that particular quadrant that your angle is in. Now you can see that in the first example A, we have our sine 300 degree is in the fourth quadrant, and you can see that sine is negative here. That means you have sine 300 degree equals minus sine 60, then you get your answer. Same for your cos. Your cos minus 60 equals to cos 300, but in this case you make it a positive because your cos is positive in the fourth quadrant, then and so on and so forth. And even for your B, your sine minus 210 degree, you just need to add 360 to that negative angle and then solve for the sine convention of the trigonometric ratio in that respective quadrant. So that's the procedure for calculating negative angles. And let me repeat again, negative angles are measured clockwise. So if you don't want to subtract, you just measure the clockwise angle. If you can draw diagrams, measure the clockwise angle, but positive angles are measured anti-clockwise. So don't forget that. Now let's move on to the last section of this video, where we'll be dealing with your graphs of trigonometric functions. So I'll just be showing us the respective graphs of different trigonometric functions. For example, let's talk about the sine curve. Now the sine curve, it is a very simple graph to draw. So all you need to do is you are going to plot if you are looking for the trigonometric graph of a trigonometric ratio, all you need to do is you plot the respective values of the angles. So you make use of your trigonometric table or your calculator. So if you're asked to plot show the curve of the sine curve from the angles of 0 to 360 degrees, all you need to do is you make use of the intervals. For example, in this case, we could make use of intervals of 90 degree or 30 degree. You can see the circle, we have intervals of 30 degree. So you can make use of that. Starting from 0, 30, 90, you can see that the angles in this circle are also drawn from in the anti-clockwise direction. So that is the convention for positive angles. Now when you draw that, you can see that you make the on the horizontal axis, it will be your value of your angles. Then on the vertical axis will be the sine of those angles. So those sine of those angles will be the heights. So and then your horizontal or your flat will be the angles themselves. So in this case, you can see that our horizontal, our positive horizontal, it ranges from 0 to 90 to 180 to 270 to 360. So those are our values. Those are our values of the angles. Then you can see that when the angle is 0, your sin theta is, when theta is 0, sin theta is 0. When theta is 90, you can see that sin theta is 1. So that is why it cuts the axis at that, the vertical axis at the 1. So when theta is 180, sin theta is 0. You can see how it goes just like a sine wave. So then in physics and in electronics, there's what we know as sine wave. So sine wave, there are different types of waves. There are sine waves and so on and so forth. Now this particular curve is the curve for the sine of angles between 0 degree and 360 degree. Now we could also talk about the cosine curve. You can see in this case the cosine curve looks just like a sine curve, but with a delay of 90 degree or pi over 2. So now this cosine curve, you can see that when theta is 0, cos is 1. So that is why it starts from the top and then goes down and then goes to the negative axis and then goes back up again. So this is the curve of cos theta from 0 degree to 360 degree. Now what is common with this curve is that they both have they both range from 0 to 360, and then they both have the same amplitude. So amplitude of a curve, these are just different terminologies you need to understand of a curve. The amplitude of a curve is basically the maximum displacement of the curve from the x-axis or the horizontal axis. So you can see that in both cases the highest points of these curves are 1 and 1. Then you also have the tangent curve, the tangent graph. Now this tangent graph is a little bit tricky to draw because it is discontinuous at some point. Now if you try pressing your calculator now, you try looking for tan 90, you will get undefined, because undefined means tan 90 is infinity. So infinity is undefined in mathematics. It is one of those few terms in mathematics that mathematicians have still not been able to successfully wield and understand. So that is why when you are drawing the tan theta curve, you will have some discontinuities. Now you can see that in this case, your tan theta goes from 0 and it goes up, then it now becomes discontinuous. So and then when the curve becomes discontinuous, that space between, you can draw an asymptote. So that is one of the properties of a curve like this. So you can see that that asymptote is the line that does not touch the curve at all. So even till it gets to infinity, it doesn't touch. But at times you'll be told in some textbooks that it touches the curve at infinity. So it depends. Now this is the tangent of from 0 to 360. You can see that it has 3 distinct sections, and you can only calculate the value of this tangent of an angle for the sections where the curve is existent or where the curve exists. So those spaces, those discontinuities, the curve does not exist. So the tangent graph is one of the graphs that denote when the curve is not defined. And then apart from this, you can also be asked to look for the inverse of the trigonometric ratios. For example, the inverse of sine is your cosec, then the inverse of your cos is your sec, and then the inverse of your tan is your cot. So you can also draw these respective graphs. All you need to do is you just need the angles, and then you need the values of these of each of these. So they will also look like this. They will also be drawn in this same manner, and they are not very difficult to draw. So if you are asked to draw, you are just going to make use of the normal way of drawing your graphs. Plot your angles on your horizontal axis, just as you can see, and then plot the trigonometric ratio of these same angles on the vertical axis, and then you connect the points with your pencil. That is how these graphs are drawn. Now, thank you for going this far with me into this video, and we have come to the end of this video, and I'll provide the summary of what we've talked about so far. So far we've talked about the 4 quadrants. We've talked about your positive quadrant, your first quadrant, which is in which all your trigonometric ratios are positive. We've also talked about the second quadrant, in which only your sine is positive. We've also talked about the third quadrant, in which only the tangent is positive. And then finally, we've talked about the fourth quadrant, in which only the cosine is positive. And then after that, we've also talked about the calculations involving the trigonometric ratios of different angles in these quadrants. And then lastly, we'll talk about the graphs of these trigonometric ratios. Now, I've provided a summary of what we've talked about so far. You can see, you can also check it out. So these are the quadrants, and if you can also screenshot it if you need the summary of all these. So, but that is all we're going to be covering in this video. Thank you for watching, and hopefully I will see you in the next episode. Good luck.